Hello and welcome to the Sociology 3, Module 11 video lecture on evaluating evidence. So in this module, we're going to continue to talk about what we talked about in Module 10 when we talked about identifying major sources of evidence that an author will likely use to support his or her conclusion. Recall that we talked about intuition, personal experiences, case examples, testimonials, and appeals to authorities or experts. And we largely focused on the major problems with using these 5 types of evidence to support an argument. That doesn't mean that they're always invalid evidence, but it does mean that we should ask the critical questions that we've learned throughout the semester to evaluate the quality of that evidence in deciding whether or not we want to accept an author's conclusion. So in this module, Module 11, we're going to continue to talk about major sources of evidence and how to evaluate these different kinds of evidence. So we're going to talk about 3 more. We're going to talk about personal observations, we're going to talk about analogies, and finally we're going to talk more about research studies. And you're probably quickly learning that almost all of the additional readings other than the Brown and Keeley text, Asking the Right Questions, our primary textbook, almost all of the other readings that I've assigned you, their major source of evidence is research studies. So that's why I'm going to focus a lot on evaluating the quality of research studies as a primary source of evidence. And when you're looking at what we would call academic sources, so books, journal articles, even the editorials that you're reading to write your own sociological editorials, the research studies is going to be the major source of evidence that you'll come across. So we're going to spend quite a bit of time on talking about that. So first let's talk about personal observation. So when we're talking about personal observation as a source of evidence, we're really talking about individuals' recollections of what they saw or what they heard. You can kind of think of this as maybe like an eyewitness testimony that one might give if they're a witness in a trial. So there are 2 major problems here. Problem 1 is that everything we see, no matter who we are, is filtered through our personal values, our personal biases, attitudes we have about any given topic, and certainly our expectations of what it is that we'll see or hear. So they're not unbiased. Personal observations are always going to be slanted, if you will, towards these particular personal inclinations. And problem number 2, relatedly, is that we tend to selectively remember the aspects of our experience and our observation that are consistent with our pre-existing beliefs. And there's a term for this called confirmation bias. We tend to pay attention to things that confirm what it is that we already think, what it is that we already believe, and we actually selectively see and hear things based on those pre-existing biases. And it's not that we're intending to be biased, it's just that's just how our brains tend to work. Recall the Sharon reading where he talked about categorical thinking. Once we start to establish certain categories and often certain stereotypes in our minds, much of what we see and hear and how we understand our social world is really filtered through and interpreted through those categories and stereotypical understandings. So very problematic. Personal observation could be a good source of evidence, but again, we want to consider these 2 problems when evaluating this type of evidence. Next, we have analogies, and you're probably wondering, why does she have a picture of a rat eating a piece of cheese? That will become very clear soon. Analogies, you're probably familiar with this word, is a comparison that relies on an important resemblance, so 2 things being similar, to make the case that if 2 things are alike in one respect, they will be alike in others. So we would say that 2 things are analogous. So when evaluating analogies, we want to ask ourselves 2 very important questions. Are the 2 things being compared actually similar in the way that the author claims or implies? And secondly, is the comparison actually relevant to the conclusion that the author's making? Because an author can draw an analogy between 2 things, but that analogy, that similarity may not really be relevant to what it is they're talking about. So this is where the rat and the cheese come in. I've got a fun example here for us. So think about this first passage here. Humans and rats have some similar physiological attributes, so physiology, the way our body works. They both like to eat cheese. When a drug company tests a drug on a lab rat and that drug has terrible side effects, we can assume that the drug will have similar effects on humans. So the author here is offering an analogy between rats and humans based on the similarity that they both like cheese to draw a comparison between how drugs will likely affect both rats and humans. So they're saying they both like cheese, so they'll respond to drugs in the same way. But hopefully your critical thinking questions, your critical thinking skills are kicking in and you're going, wait a second, just because rats and humans both like cheese doesn't necessarily mean that their bodies will physiologically react to drugs in the same way. So are the two things being compared here actually similar in the way the author claims? Let's assume that humans actually like cheese. Not all of us do. It's one of my favorite foods. Okay, so let's assume that's true. So the answer to the first question is yes, but is the comparison relevant to the conclusion? Not necessarily. So let's look at this second passage, which is a much better analogy according to these two questions I'm giving you here. Humans and rats have some similar physiological attributes. As mammals, both humans and rats process chemical substances in similar ways. When a drug company tests a drug on a lab rat and that drug has terrible side effects, we can assume that the drug will have similar effects on humans. Now, ask yourself, why is this a much better analogy as a source of evidence for this author's conclusion? Well, if you guessed that, right, it's that second sentence, as mammals, both humans and rats process chemical substances in similar ways, you're absolutely right. That analogy, that similarity is directly relevant to the conclusion about when drug companies test a drug on a lab rat and it has terrible side effects, we can assume, because both rats and humans are mammals, that they will respond to drugs in the same way. So it meets these two criteria that I have under evaluating analogies. Are the two things being compared actually similar? Yes. And is the comparison relevant to the conclusion? Yes. So that second one is a much better analogy. So anytime you come across an analogy, ask yourself those two questions as a way to evaluate the quality of that analogy. So finally, we're going to focus on research studies as evidence. Again, this is the most common source of evidence that you'll come across in this class and probably in most of your classes here at college and in your professional life. So research studies consist of publicly verifiable data collected and analyzed specifically according to the principles of the scientific method. And you've probably been learning about the scientific method going all the way back to elementary or middle school. But I want to really focus on three major principles that are central to the scientific method's way of analyzing and trying to understand social life, physiology, pretty much everything it is that we study. The first one is replication, and this involves the collection of data under conditions such that other qualified people, other scientists, can make similar observations and they would get the same results. So basically, a study has to be replicable. You have to be able to replicate not only the design of the study, how the study was set up, but you also have to be able to analyze the results in the same way to see if you get the same findings. Second major principle is control. So the scientific method really strives to use research procedures that reduce error in observation and interpretation of research findings. So recall when we were talking about the problems with personal observation as a source of evidence, personal biases, attitudes, confirmation bias, etc. This control principle really is about using procedures that try to pull that personal bias out of the research process. So very important here. And the final principle is precision. So the scientific method strives to use very precise definitions of measurable concepts to avoid confusion and ambiguity. And we talked about ambiguity in a previous module. If you'll recall, ambiguity means, right, something, a term, a concept, can have different meanings for different people. So in the scientific method, what scientists really strive to do is to define their concepts in very specific, concrete ways that allow them to measure it. And that very long word there in parentheses, operationalization, basically means that you're measuring a concept, you're defining a concept in a way that you can measure it and that different people can measure it in the same way. So for example, think about study habits. Think if we were interested in studying college students' study habits. How might we operationalize? How might we precisely define what study habits are? One way of doing that would be to calculate how many hours per week each student studies. Another way of doing it might be the different study methods. So you can see how those are two different ways of measuring the concept of study habits, but a researcher would have to be very, very precise about how he or she is measuring that as they go about doing the research. Now, there are a lot of problems. I know there's a lot of text on this slide, bear with me. There are a lot of common problems with research studies as evidence. So there's problems with every kind of evidence, potential problems at least, right? So again, the point here is not that we can't use all these different sources of evidence to support a conclusion, but it does mean, right, that we should be using our critical thinking questions. So Brown and Keeley go over this in the chapter for this week, but I want to highlight several things here. Research can definitely vary in quality and often does. Not all research studies adhere to the principles of the scientific method. Another issue is that research findings are often contradictory. Study A might find something different than study B. Research findings can only lend support to a conclusion. They cannot prove conclusions conclusively. So be very skeptical when anyone says this research project proves X. No, you can't prove. You can lend support to, but you can't prove it definitively. Researchers are humans too. I myself am a researcher. I know many of you are interested in going to graduate school and researching different topics. We're human beings, right? We too are influenced by personal biases, values, attitudes, and incentives for professional and financial gain. So anytime there's a human being conducting the research, there's always a potential for these biases to influence the research process. Probably know about the next one just from reading newspaper articles, but we know that research findings are often simplified and distorted for public consumption. So the way that research findings are often reported to the public doesn't really accurately reflect what the research actually revealed. So you have to be really careful, especially when you're reading something that's for the popular media. Research findings change over time. Social processes, physiological processes change over time. So you have to keep in mind that research study A conducted in 2010 might have found something very different than research study B on the same topic conducted in 2015. Another thing is that many research studies are conducted under artificial conditions that really limit the applicability of the research studies findings to real-world conditions. So what do I mean by artificial conditions? Artificial conditions mean basically can mean in a lab, in a laboratory environment, or if you're doing, say, you're interviewing people. It's a very common method that sociologists use, a qualitative method that sociologists use. Sometimes the conditions in a lab, or when you're trying to study people's response, say, to a movie as part of an experiment, if you remove people from their actual social context, they may not have the same responses because the conditions are very different, right? We might say that I'm showing you a film in class versus you watching the film at home. Watching the film in those two different contexts might radically alter how you experience the film viewing. And then last, many research studies are not generalizable. And this term generalizable is a very, very important one. So generalizable means, can we take what we learned from a research study on one subset of a population? So population is, say that we were studying the Fresno State student body. There's about 25,000 of you if you include graduate students. Say we only studied 1,000 of them. Say it was a survey design. Can we actually say that what we found based on surveying 1,000 Fresno State students is generalizable to that larger population of 25,000? And sometimes the answer is yes, and we're going to talk about ways that researchers can ensure generalizability, but sometimes the answer is no, so you always have to ask that question. So how do we address these common problems of research studies? So a lot of it has to do with what we call sampling. So first of all, researchers want to make sure that anytime that they're focusing on a study sample, say our 1,000 Fresno State students out of that larger 25,000, we want to make sure that they're selected from a representative segment of the population that is similarly diverse in terms of the important variables that we're interested in.